Hello, 8th graders. Today we are going to talk about chapter 5 in our iBook, and that is on solar and lunar eclipses. All right, so we've talked about our lunar phases and where the moon is in relation to the Earth and the Sun throughout its orbit around the Sun, or throughout its orbit around Earth and Earth's orbit around the Sun. Okay, so that we've got two different kinds of eclipses. What you may have noticed when we did the simulation of the moon phases is that sometimes everything is perfectly aligned. So let me just go to full screen here and we'll give this a shot. Here's my sun, okay? And so if we've got the Earth right here, okay, so this would be the daytime side of the Earth, this would be the nighttime side, and we've got the moon right here. When the moon is in the middle, remember that we see the dark side of the moon. That would be a new moon. And as we move around the sun or the Earth, the moonlit side of the lit side of the moon gets larger, right? So all of these phases here are in their waxing phase until we get over here to the full moon, okay? Well, the moon's orbit around the Earth is tilted a little bit. It's not in perfect line. If it was, we would get a eclipse right here at a new moon phase, and we would also get an eclipse right here at the full moon stage every single month. But because it's tilted a little bit, the moon actually ends up here, all right? So when the moon's up here, this is the full moon stage, we see the full face of the moon. Sometimes it lines up so that the moon ends up right in Earth's shadow, and that would be a lunar eclipse, and we'll talk about what that looks like, okay? When we get back over here during a new moon phase, this would be, the Earth is facing the sun. This would be the daylight time or the daytime side of the Earth. When the moon moves in front of it, sometimes it blocks out, if it is the perfect distance away from the sun and away from Earth, it will block out the disk of the sun during the day. And that would result in a solar eclipse. And that happens much less frequently. It's a very, very cool thing to witness when it does happen. And then there are varying degrees of partial eclipses for solar eclipses and partial eclipses for lunar eclipses. Okay? If we go back to the book, it says ancient people could not predict eclipses and didn't know when one would happen or even if they would end. And so it totally freaked them out, right? I mean, imagine if you didn't have a good understanding of how the Earth, Moon, and Sun were arranged in the sky, and all of a sudden during the day the sun turned black during a solar eclipse. Kind of freaked them out. And so they would go through different rituals. They would dance around and try to chase the demon away from the sun, and inevitably it always worked, right? The moon always moved beyond the sun, and the sun came back out and life returned to normal. We know now that it is the geometry of where the sun is, where the Earth is, and where the moon is that allows for eclipses every so often, and we can predict when those are going to happen right down to the minute. Okay. A solar eclipse occurs when a new moon, has to be in the new moon phase, passes directly between the Earth and the sun. All right, so we always put the moon back in the middle when we're starting our moon phases, right? That's the new moon. But again, sometimes if it is on the day, if you're on Earth during the day and that happens and it's aligned perfectly, it can actually cover up the entire disk of the sun. Okay, now if we look down here, on Earth, if we're standing here on Earth and the moon blocks the sun, look at this tiny little piece right here. This little pinpoint is the only place on Earth where you're actually going to see a total solar eclipse. If you're over here in this shadow, you're going to see a partial eclipse. If you're over here in this shadow, you're going to see a partial eclipse. But only the people that are on this little pinpoint, and this little pinpoint kind of wraps around the Earth during the movement of the eclipse, that line is called the path of totality. It's kind of like putting a spaghetti noodle on a basketball, okay? So a very tiny little line around the Earth will actually see the total solar eclipse when it's happening, which is why it's so rare, okay? It's not rare, it's rare for it to happen, maybe once every couple years, but even more rare for you to be in the right place to see it. Okay, so it's kind of a once in a lifetime event. All right. A lunar eclipse is a little bit different. A lunar eclipse occurs when the full moon moves through Earth's shadow. Again, normally we have a tilted orbit around the Earth, and so the moon is up here and we actually see the full disk of the moon. But sometimes it lines up perfectly, so we are shadowed. The moon is shadowed, and it actually casts kind of a red hue on the moon. That's what this picture is at the beginning here. This would be a lunar eclipse. Whereas down here, this would be a solar eclipse, okay? And you can see this is a picture of the Earth from space during a solar eclipse. This is the only spot, right, that people can actually see the total solar eclipse. This spot is going to move across the Earth as the moon moves, but only a few people, if you happen to be in the right place at the right time, are going to actually see the total solar eclipse. All right. The next part is there's a couple different kinds of shadows during an eclipse. Okay, we've got the umbra, which is the total shadow. Okay, that's going to block out all of the light. Okay, so in this situation, this is a lunar eclipse. Here's the sun, here is the Earth. Lunar eclipses are much more common because if it lines up, anybody on the nighttime side of the Earth is going to be able to see it. Okay, so all of these people on this side of the Earth will see a lunar eclipse, which is why it is not as rare. It happens a couple times a year, and we see one, about every year or so, depending upon where you are on Earth. All right. If you see the moon in this part, this penumbra, which is a partial shadow, you will see a partial lunar eclipse. Okay, and we're going to be drawing out this geometry and talking a little bit more about what the umbra and the penumbra means. I'm just kind of giving you a quick overview here. It says a total lunar eclipse occurs when the moon travels completely in Earth's umbra. During a partial lunar eclipse, only a portion of the moon enters the Earth's umbra. Earth's shadow is large enough that a lunar eclipse lasts for hours and can be seen by any part of the Earth with a view of the moon at the time of the eclipse. So if you're on the nighttime side of the Earth. A lunar eclipse does not occur every month because, again, the moon's orbit is inclined a little bit. It's inclined about 5 degrees to Earth's. If it was right on the same line, we would have a lunar eclipse and a solar eclipse every month. That would be really cool, but again, it wouldn't be so unique, right? I'm going to post a couple videos that go along with this and ask you a couple questions. The videos will show you a little bit more about what you would see, what you would actually see if you witness one of these types of eclipses. And we're going to talk more about eclipses, and I'm going to talk a little bit more about my experience being able to see the total solar eclipse a few years ago when we talk again. All right, I hope you're well. Talk to you soon.